Hello. Today we're going to be working on lesson 3.1. So if you can turn to your course pack. So we are going to look at measures of central tendency, aka center. Measures of center. There's three measures of center that we're going to look at for quantitative data. So the arithmetic mean is computed by adding all the values of the variable in the data set and dividing by the number of observations. Sometimes we call this the average. In our course, it will be referenced as the mean. The median, which is the numerical value separating the lower half of the data set from the upper half. So 50% is below this value and 50% is above this value. And then the mode. The mode is the most frequent observation of the variables that occurs in the data set. So let's look at how we can find these. So we asked the question on the survey, how many pets do you have? And so I'm going to take you to StatCrunch. So if you could turn on StatCrunch, that would be helpful. Well, actually my Stat Lab. So when you get to my Stat Lab, right in here it says StatCrunch. And then when you click on that right here, it says StatCrunch website. Sometimes you have to exit out and go back in it again. But the first thing you're going to want to do is to subscribe to my data. And I set that up in your scavenger hunt. And under my data, so you're going to go into my groups right here, my groups. And you're going to click on Stats SP21. And then in our data here is actually on this third page, I believe. It should say right here, project, chapter 1, project student survey, SP21 responses. So go ahead and click on that. And these are all the answers to data I collected. And we're going to the one that says how many pets. It's right next to this one's in your house. This one is how many pets. So what is, so you can make them wider. So you can make that wider so you can see that it says how many pets do you own. So we have all of these data points here. Now, I'm not going to write them all out. I'm going to teach you how to find the mean and the median using StatCrunch. So we're going to go to Stat and Summary Statistics into Columns. And I'm going to write this on my paper so we can follow in the middle. So Stat, Summary Statistics, and Columns. And then it's going to let you choose here which one you want. So you're going to scroll down until you get to how many pets do you have, how many pets do you have. And when you click on it, it should go into the right-hand box. Now, we are not going to use the grouping by or anything. And we're just going to let it calculate the statistics over here that are listed right here in the white. And hit compute. And you should get this. So the little n, let's write that on our paper, is 63. That means there were 63 people that answered this question. And the mean is 3.079. So I want you to write that down, the word mean, right here, 3.079. I'm going to skip this other things. We're going to learn about those in the next couple lessons, but then you're going to go right here to median. And then you're going to write the word median. And under that, you can write 2. So the mean is 3.079 and the median is 2. Okay. Now I'm going to go back to my paper because I want to show you what my paper looks like. For some reason, this does not want to go. So I wrote at the top here, stats, summary stats, and columns. And then we chose how many pets do you have. And it's the number of observations, number of students who answered the survey. And then here, because we didn't write it on paper, we collected it on a computer. The mean is 3.079, and there's going to be 2 symbols for that. We're actually going to talk about in the in a minute. But the one that we have is not every student at Jackson College. It's just a sample from our class. So it's going to be the X bar mean, okay? And the median, usually we'll just say it's MED, okay? So for now, just write that. Now, on the next page, it says place a dot on the second dot plot whiteboard for your number of pets. Draw an accurate sketch of the class's dot plot. So let's go back here to the data. And we should have 63 dots because 63 people answered. So the first person said that they had 1 pet. So I'm going to mark a dot at the 1 on my graph. And then there was a 2. And then a 6. And then there was another 2. And so I'm going to mark that on top of the other dot. And then there was a 4. And a 5. And another 2. And a 0. So far we have a 1, a 2, a 6, a 2, a 4, a 5, a 2, and a 0. And let's stop there. And that is actually 7. That's actually 8 people. Okay, so I'm going to show you what my paper looks like so far. So it looks like this. So the multiple 2s, you're going to just draw the dots on top of each other. Okay. So let's go back and draw the rest. And we were at that first 0 right here. So now I'm going to do a 4, a 1, another 0, and then a 5, a 1, and 2 zeros. 5, a 1, and 2 zeros. So then right here. So 1, a 2, and a 3. A 1, a 2, and a 3. That's our first 3. And then a 1, a 1, a 3. 1, a 1, and a 3. And then we have a 1 and a 1 and a 10. A 1 and a 1 and 10. And interestingly enough, on the 10, oops. On the 10, it's really a 10 plus. It could have been more than 10, but we just had them answer a 10. So now we're here at the 4. So see. So 4 and a 3 and a 4. 4, 3, and a 4. 5, 3, and 1. 5, 3, and a 1. And another 10. And then 7, 2, 1, 1. 7, 2, 1, 1. 3 and a 10. 3 and 10. Right there. Now we have 1, 2, 1, 1. 1, 2, 1, 1. 10. 3, 5, and a 1. I'll write this 10. So 10, 3, 6. 10, 3, 6, 4, 7, 1. 4, 7, 1. And our ones are definitely above our top, right? I think we have 13, 14, 15, 16 ones is what I have so far. So we have 0, 2, 2, 0, 0, 2, 2, 0. We're at the 7 here. I'm just going to scroll down. And we have 7, 2, 2, 2. 7, 2, 2, 2. 3, 5, 3, and a 1. Okay. This is what mine looks like. So it says, definitely looks like 1 is the mode, because the mode is the value that occurs the most frequently. So let's find that page that we were just on, that first page. And the mode is equal to 1. 1 is definitely the one that occurs the most. But the mean is 3.079 and the median is 2. So this is interesting. Which one should we choose to be the best? Okay. It says, what is the shape of our data? Skewed left, skewed right, or symmetric? Explain why. So we talked about this back in chapter 2. And it definitely looks like it's skewed right because there's some of these data points here, right? These, that was a 0, so we don't count that. And that's a 0. So the first one started up here. So 1, 2, 3, 4. There's 5 people that had 10 plus pets. So that means they could be out here. So these people with all these pets is really pulling our average up higher. That's why our mean says 3.079. But really the most frequent value is a 1. So we're going to say skewed right. Because students with 10 plus pets is pulling up the mean. So this is label where the mean, median, and mode appear in the dot plot above. Okay. So here's the mode for sure. 3.079, there's the mean. And the median was 2. And remember that the median is where half of the data is above that value and half is below. So it says relating mean, median, mode to graphs, histograms, dot plots. So the mean appears as the smoothing out point, really. So the mean is where if we had some of these people, right, these people with 10 pets, share some of their pets with people over here, right, we would kind of blend it in and that would fall in about where everybody would have about 3.07 pets. the median appears as 50% of values below, 50% above, and the mode appears as the most dots. There you go. Okay. So topic 2, a little bit more about the mean and median. So the mean median mode for our class was 1 extra member. Someone shows up and they inform us that they have 127 pets. This actually happened one time. This was my student. She had a bunch of tarantulas. Yes, it was pretty funny. So this is, what does this do to our graph? Okay. So in this case, we're going to have this 127 person out here, right? They're going to have 1 pet. And I'm just going to summarize this. I'm going to make it look more like a histogram. That from our chapter 2 learning. So that is where we had 6 people that had 0. And then we had 12, 13, 14, 15, 16, 17 people that had 1. So remember, now look down here, it goes 0, 3, 6. So the 0, 1, and 2s are all kind of together, right? And 2 had 11. And then 3 pets. There were 9 people that had 3 pets. And then there were 5 people that had 4 pets and 5 people that had 5 pets. So a couple there, and then the 6 pets was 3, and then 7 pets. Oh, oops, 6 pets was 2, and 7 pets. And then 8 and 9 had none, and then 10 were 1, 2, 3, 4, 5. And we can even see the 10 in here, and they had 5. So that really skews out our data now, right? Because we're like this. So one thing we want to mention down here is it says, what do you notice about the student affected the mean? So if we added the student in, the median, the mode would stay at 1, right? Because it still has the most number. Let's go to our data set here, and just for a minute, we'll add that student in and see what it does. We're just going to add this in. 127 pets right there. Okay. I'm going to go to stat and calculators and columns again. I'm going to choose how many pets do you have and compute. And you can see that our mean went up to, the X bar went up to 5.016, and the median stayed right at 2. So the only thing that was really affected was our mean. So the mean is sensitive to outliers in the data set, unusually large or small values, i.e. the 127, while the median and mode are resistant. They are not affected by those outliers. The mean is very much affected. Okay. So it says, which measure is a better representation of our class's pet ownership? So here I would say the median at 2. And the reason I chose that one instead of the 1 of the mode, because the mode doesn't take into account any of the other values besides the fact that it occurred the most. So I'd say the median is the best. So important point number 2 says, when data are skewed left or right, it doesn't matter which, the median is always the preferred measure of central tendency over the arithmetic mean. Okay, always. So let's put that here in context of picture. Okay, so our shape here, it's wherever it's thin is where our shape is skewed. So it is skewed left. And notice here, that means the mean is less than the median. We always write the mean on the left. I do. So mean compared to median. So the mean is less than a median in this case. Okay. And the median is always the best measure of center when it's skewed. So let's get down here because this one is also a skewed data set, but this one is skewed right. And that's because the mean this time is greater than the median. And again, the median is the best measure of center. Now here, where our shape is symmetric, meaning we can draw a line down the middle, that should be our mean. And half on the left is going to look a lot like the half on the right. And so we say our shape is symmetric. And that's because our mean is approximately equal to the median. They're not going to be exactly equal, but they're approximately equal. In that case, we're going to say the best measure of center is the mean. For this case here. Okay. So let's take a look at our example here on page 79. We were given 3 histograms. It says match the mean and median combinations to the appropriate graphs and explain. Okay. So just looking at the pictures, let's just look at the shape here. We would definitely say that this is a skewed right, meaning that the mean is greater than the median. And remember, wherever the arrow on the inequality is pointing, when you write the mean on the left and the median on the right, alphabetically, MEA comes before MED. That's why we do that. And so when it's pointing to the right, it's skewed right. So we know this must be true. So let's look and see which ones where that's true, where the mean is greater than the median. So B is a possibility. And E is a possibility. Okay, so how do we choose which one is the better choice here? Well, 6.4 and 6.2 are actually pretty close together. Oh, F is also a possibility. But I'm going to say, let's look at the median, because the median is where half of the data is above and half is below. Okay, so if we added up, these are frequencies. If we added these up, this would be about 22, we'll say, values. We'll call that 9, 8, we'll call that 11, we'll call this one 27, we'll call this one 5 and 2. That one's going to be 6 and 3, and then 2, 2, and 1. 2, 2, and 1. So let's just add these up and it'll tell us about how many data points were in each. So 22 plus 1 plus 27 plus 8 plus 11 plus 5. So I underestimated them somehow because there's only 98. So there really should be 100 data values here. Okay, so this should be about 100. So if there are about 100, that means 50 of the data values would fall to the left of the median. So let's start adding. 22 plus 9 is 31, plus 27 is 58. That means our 51st data value, right? Because the 50 have to be below the median and 50 have to be above. So the median has to be in this bucket somewhere. Okay, in this bucket, which is between 3 and, so that's 1, 2, 3, 4, 5. So it's in about the 4. So the mean at 4.1 or the mean at 4.3. I meant the median at 4.1 or the median at 4.3. Now, so we could choose either of these, but because this one here, 5.1 and 4.1, they're relatively close together, I would say it's probably not that, and it's definitely not the 6.2. So I would say it's this one here where the median is at 4.3 and the mean is definitely quite a bit bigger because of the skewed data here. So we're going to say that this one is B. So we've used B. Okay, that's kind of how we do this. Now let's look at the one here. This one is definitely a skewed left data set. So we know that the mean is less than the median this time. And so let's circle all the ones that could be the mean is less than the median. So it could be A, C, or D. And we're going to look at the median again. So do we think the median is 5.4, 5.3, or 5.2? And with a mean of 5.2, 4.1, or 4.8. So it's going to be pulled this way. So my guess is it's going to be more like D. Because the median, there's very few that are over here. See, on this one, it was skewed. There were quite a bit that were kind of further from the mean. This one doesn't have very many that are, it's slightly skewed. So I would say in this case, this one would be D, where it's skewed, but not a whole lot. Now, don't worry. These are not the kinds of questions we give you on the midterm and the final. These are the thinking questions that kind of get us thinking while we're in class and we're working with each other and just trying to build some concepts. So it's okay to struggle a little bit. Now on this one looks pretty symmetric, right? It's pretty uniform. So we would say the mean on this one would be pretty close to whatever it is. And in this case, I would say that that's A, right around 5. So 5.2 and 5.4. The mean and the median are close together. So this one's going to be A. So example 4, almost done here with lesson 3.1. Consider the following graph showing the disparity in retirement savings in the U.S. across racial ethnicity groups. So the blue are white, Caucasian, the green is the Black African American, and the red is the Hispanic. Years are on the bottom, and the median family retirement savings is on the vertical. Explain why this graph is discussing median retirement family savings. Why is discussing median? Well, because the mean is probably a skewed value. So the data is most likely skewed. So the median is the best measure of center. That's why they showed that. Okay. Down below it says median is actually the preferred average for many economic and financial indicators such as income, net worth, household income, home value, etc. And that's because there's very few people at the top and they skew everything to the right. So it's most likely skewed right. Okay. Next up. we're going to find the mode, although the mode is the measure of something that we use very least, so I'm not really going to spend much time talking about it. So in this data set, find the mode. There is none, because none of the values happen more than once. In the second data set, we have a mode of 1 and 3. So 1 and 3, they both happen twice. And this is called bimodal because there's two modes. The mode birth country for the 2019-20 Detroit Red Wings player was Canada. It has 11 players that were all born in Canada. And it just says, what are some disadvantages and advantages of the mode? The disadvantages, it doesn't show if the data is skewed. An advantage is it's usually easy to find. One disadvantage is you have to do it by hand. So that's one disadvantage with a large data set. So yeah, and this is best for categorical data. So it's best for categorical data. Like this here. Eye color is another good one because there's few. Blood type would be another good one to go on. So our last page in lesson 3.1 has us kind of look at the symbols that we're going to use for mean. So remember back in chapter 1, we talked about population and sample. Population is if we have observations from every single person or item in our that we're trying to observe. Then we're saying that we have the population mean. It's a parameter. So the population mean, the characteristic is called a parameter. P goes with P. It's data from the whole population. It does not vary. It's always the same because it's the whole population. And that symbol is mu. Okay, we pronounce it mu, kind of like what a cat says. The sample mean is this symbol, and we say this out loud, X bar. And the more that you can say these words out loud, the more comfortable you're going to become this semester. We call this measure characteristic a statistic. S goes with S, so sample goes with statistic. This is data from a sample, and it varies from sample to sample, but the mean and the X bar will be close. They're going to be different, okay? They will be different, usually. So mu and X bar will, let's just write, not be the same, but should be close. As long as the sample was random and large enough. And we're going to talk about those things later on this semester. Okay, the difference between mu and X bar will be very important from chapters 8 to 11. There are actually two medians and two modes as well, but this is less important for our course. So we're only going to focus on the differences in the mean and the median. I'm sorry, the mean for the population and the sample. So you can think about this for the sample of X bar of human body temperatures. You could just take a sample of people. Mine, I tend to be right around 97.3 every time I take my temperature, but we say that the mean body temperature of all humans is right around 98.6 degrees. Okay. So example 6 says, is the mean we found for the pet data in example 1 a sample mean or population? And I said sample mean because we only had data from our class. not all JC students. Now, we could have said our class is the population, and so we had data from everybody in our population, right? And that if we would have taken a sample of our students, then that would have been different. So kind of decide, you have to decide what are you measuring as your population? And that will define if you have a sample or a population data. So that's all for 3.1. Catch us back for 3.2.